Yes, dimensional analysis can be used for density calculations because density is defined as mass divided by volume. So converting units of mass and volume with factors lets you compute density in any desired units. Think of dimensional analysis like using a measuring tape that also changes units for you. Density equals how much stuff you have in a certain space. So if you have mass in grams and volume in milliliters, but need grams per cubic centimeter, you use conversion factors to switch the volume units and keep the ratio consistent. You write the value, multiply by conversion fractions that cancel unwanted units and stop when only the units you want remain. That keeps the numbers and units matched correctly. If the mass and volume are in compatible units, the arithmetic gives a number, and the final units tell you the type of density, like kilograms per cubic meter or grams per cubic centimeter. Always track units as you calculate so you do not mix up mass and volume or forget to cube linear conversions for volume changes. Students often forget to cube linear conversion factors when converting volume units, which makes the result off by big factors. To fix this, raise the linear conversion to the third power for cubic units and cancel units carefully. Another common mistake is mixing mass and weight units or using different mass units without converting, which leads to wrong numbers. Make sure all mass measurements are in the same unit before dividing by volume. Some people cancel units incorrectly by treating units like labels instead of algebraic quantities. Treat units like numbers and cancel them step by step, so the final unit is the density unit you expect. Check out www.gumballdegree.com for more videos and resources on using dimensional analysis for density and other chemistry topics.